So, in this lecture, I'll talk about counting rules. Now, these might seem straightforward, but actually, this is some of the hardest stuff because it should be obvious. So, simple counting rules. Consider selecting, so this is the general, consider selecting or objects from a group of n distinct objects. Sampling with replacement, the total number of possible objects. So, the classic one for this would be, you know, there's a bag and you have a couple of balls in the bag and you take a ball out and then you take another ball out and it keeps on going like that. They would be the classic sample ones, yeah? So ball, bag, bag, bag. And what you do is how many different ways can you take each ball out? So each ball is numbered 1, 2, 3. So you take a ball out, you put it back in. You take another ball out, you put it back in. So how many different ways of doing this, yeah? So if you take out 2 balls, how many different ways, how many different versions, and it keeps going and going and going. So that's what it means by this is that if you play the game once, so if I take out 2, there are 2 possible. Then again, then again, then again. So, and if I do it or times, that's how many times. So every single time you keep adding and adding and adding, yeah? So the actual simplest version of this is you're playing a game of bingo, but the ball keeps going back in. And every time they can keep on pulling out the same ball. So there's 10 possibilities every single time. So how many different possibilities? 10. Once again, 10, 10, 10, 10. Now, what happens if you change the rule? So, consider selecting or sampling or objects from a group n. Sample without replacement. So, in this example, you have your balls in your bag, you take one out, and it's gone. You won't see it again. Yeah. So now there's 2 left. Take another one out. So there's 1 left. So in the example of 3 balls, if you do it 3 times, first time there's 3 possibilities, second time there's 2 possibilities, and third time there's 1 possibility. Yeah. So how many different ways can you arrange 3 balls? 6 different ways. Yeah. So you could have ball 1, ball 2, ball 3, or red, green, blue, blue, green, red, and all that. And in this tutorial, I'll actually do a lot of writing out how many different permutations, because actually with this kind of stuff, it's good to write out the full sample space. Now, this is another variation. Selecting or sampling from a group, what's the total number of possibilities when order does not matter? Yeah. So this is funny, you're going, okay, well, I have 3 balls and I want to select 1. How many different ways can I select 3 balls? 1 from 3? Well, that's just 3, that's obvious enough, yeah? How many different ways can I select the 2 left over? Well, there's 2 possible balls there, yeah? And how many different ways can I select the last one? There's 1. Oh, well, that's like before, that's 3 by 2 by 1, which is 6. But order does not matter. So now, you could have a yellow, blue, green, yellow, whatever way they came out, but you don't care. So actually what happens is, this is then divided by 1 by 2 by 3. So what that means is there's only one way to get 3 balls from a bag. Yeah. And once again, in the tutorial, we'll deal more with that. And this can become more and more complicated. Like I have to think about different rules, but number of distinct arrangement of n objects, of which n1 is 1 kind, n2 is another kind, all the way out to the different kinds. It's a multinomial. So what's the probability of 6 throws of a fair dice, all faces turn up. A fair coin. Actually, the better one is picking a football team. And we'll go through an example of that. You only in theory, a football team has 21 players, we'll say, in the squad. 3 of them are goalkeepers. So do you say 21 people can play in goal, or do you only say 3 people can play in goal? So you have to think a bit about that. And how many different ways can you choose those 3 people? Well, in the end, 1. And we'll go through examples. The easiest one to think about of this would be the PIN number, which is simple. You get issued a bank PIN, numbers are between 0 and 9, so that's 10 possible numbers. So how many different PIN numbers do you have? Well, 10 possible numbers for the first one, 10 possible numbers for the second one, 10 possible numbers for the third one, and 10 possible numbers for the fourth one. Yeah? That makes sense. So we have 10,000, 10 by 10 by 10, or 10 to the power of 4. Yeah? That's our first rule. Now the digits must be different. So if we have, the digit has to be different. The first digit, you have 10 possibilities. All numbers are possible. But as soon as you have that possibility gone, you have 9 now. So it's 9. So you've used another digit, 8, and then 7. Yeah? Because it counts down. You can't reuse a digit, so therefore it counts down. Now, you can have loads of different rules, like what happens if every second digit has to be different? Yeah? So it'd be 10, 9, 10, 9, 10, 9, 10, 9. Yeah? But actually, that's not true. It'd be 10, 9, 9, 9, 9. Think about that one. That one's a bit more difficult. And that's the kind of game to play. And then in the tutorial, I'll talk a good bit about card playing, because that's a really nice one because it's quite structured. So poker is straightforward enough. 5-card poker, how many different possible hands are there? Well, there's 52 cards, 52 by 51 by... Order does not matter in the hand you're dealt. So it has to be divided by something. With a pair, you're choosing an exact number. So we'll talk about a lot of that in the tutorial.